So our next step is we're going to look at micrometers. Micrometers, actually, here, let me pull one out for you to look at. I actually have some of these. Look like the big C-clamp. That's this thing here. They're not just a clamp, no. Now the one thing you'll notice, you can see I'm turning this sucker a lot and it's not moving very fast. Most micrometers, I have seen micrometers out there that have more than 1 inch of travel, but most micrometers have only 1 inch of travel. So most of your micrometers only measure between 0 and 1 inch. If I want to measure something larger, you have to have a 1-2 micrometer. So that measures between 1 and 2 inches. It'll never go smaller than 1 inch because you'd have to crank forever to get it to go that far. So most of them are only given, and it's also the other reason is because the threads that are used, each full revolution of this is exactly 1/10 of an inch. If I'm thinking right, no. What is it? Each full revolution is,
Well, some of them
I don't remember now what it is. Yeah, each full revolution is 25 thousandths of an inch. That's what I'm trying to remember. It's 25 thousandths of an inch. So that is pretty fine threads. So it's also rather expensive to thread these. So if you wanted to thread it for more than 1 full inch, it would be kind of pricey as well. So that's another reason why they only thread 1 inch of travel on them.
Yeah, you wonder how many of them don't qualify after the machine.
You gotta wonder, yeah, if after they get done with them, how many of them get rejected and sent off. You always wonder, the biggest thing in industry, when it comes to precision machining like something like this, is a little bit of a side note, is secondary markets. A good engineering staff will take something like this where they know there's going to be a large percent. Let's say it's even just 10% that's rejected. Well, that can either be a loss, so you have to raise the price of the item to account for that, or you have a secondary market where, okay, I've got some other part that I use that same threading on, but it doesn't have to be quite as exact. So anything that's rejected for this, that same piece can be put off and used for that. Most of your military contracts, by the way, that's where the profit is. You hear about the U.S. government spending $6,000 for a hammer or something like that. That's not an exaggeration. There's some truth to that. Yeah. Well, the toilet seat is an exaggeration. Well, could be an exaggeration depending on what it's for. For like a bolt for in a tank, put it that way. A single bolt that you could go up to Farm and Fleet and get for like 60 cents. One of those bolts for in a tank could cost $40, $50. Why? Well, the ones you get at Farm and Fleet, there's a huge tolerance in the threads between the bolt and the nut. You ever tighten one up on something that vibrates a lot and have it loosen up, so you got to tighten it up again and again? Well, they use lock nuts or lock washers or whatever. The reason it loosens up is because there's slop between the bolt and the nut. So when it vibrates, it allows it to wiggle back and forth, and as it starts wiggling, then it can slowly start to revolve and turn. If there is no slop between them, that's also why you can hand tighten the nut on the bolt, by the way, because of that slop. If there is no slop, that nut cannot wiggle on the bolt and it won't come loose. Well, you can imagine on like an airplane or a tank, it's kind of important that they don't come loose and fall off. There is no slop. If you take a military grade bolt and nut, you cannot hardly even start that nut on the bolt without a wrench because there's no tolerance, there's no slop between them in the threads. So when they manufacture those, they are manufactured in pairs. The bolt is paired with the nut that goes with it because they're not universal like they are with other ones because there's no tolerance between them. So they may produce 100 nut bolt combinations to get one that meets specs. Well, the military is going to pay for all 100 of them. In fact, they generally don't even pay for all 100 of them. They pay, the company doesn't charge them for all 100 of them. Most companies take a loss on military contracts. So where do they get their profit from? They take the 99 rejects and they sell them on the secondary market for something else. They're still very, very, very high quality compared to most of what's out there. They're just not military quality. So I know it's a little side note, but
some companies will market things as mil spec when they're rejects from mil spec.
Yeah. But they're still higher quality than standard pieces, but so anyway, something else I wanted to show you here. At the very end here, you see there's this little smaller knob. When you get close to being tight, that's what you use, kind of like on the caliper, you had the little thumb, the wheel. I don't know if you can hear it. That's a little ratchet so that you can only tighten it a certain amount. Because, and I'll show you this is really bad for it, but I don't care, it's a good lesson. I don't know if you can see it on there, how that lines up with the 0 across there. If I take it and reef on it, I can turn it about 5 thousandths past 0 by over tightening it. Like I said, it's not real good for it. I'm going to loosen that up right away because I actually have a set. So I think I gave them to the Success Center to use. I had a set somewhere that were over tightened where these were all bent, so they were several thousandths off of true because the head of the micrometer was bent from being over tightened. So you never. I mean, this is fairly sturdy, but they still can bend. They're basically aluminum for the most part. So be careful with them. So anyway, how do you read the scale? Well, you have the barrel, and then you have the thimble. The thimble is the part that rotates. The barrel is connected rigidly to the jaws. The thimble is the part that turns. On the barrel, for an inch micrometer, these little markings here are tenths of an inch. So this would be 0.1, 0.2, 0.3 inches. In between are the quarter marks. So what that means is, in between here, this is 25 thousandths, so that's 0.025. So this right here is 0.125 inches. This is 0.150, this is 0.175, this is 0.275. So right now this is 0.325, 50. How do I know I'm past the 50? Well, what's this go up to? Goes up 25. 15 means I'm closer to coming around to it than I am going past it. I'm not to the 50 yet. So this is 0.325. And then here's another 15, and that is 15 thousandths. So it should be a 0.340 inches is what that should be reading. Now here they read the tenths and then the quarters separately. I always read the tenths and quarters together just because I try to shorten things up as much as I can. We'll come back to the inside and the metric in a little bit. Let's actually read a few of these. So this one is what? 0.225 plus 15, so that makes it 0.240. This one, tell me where to start. 0.425, and there's nothing there, so it's just 0.425. This one? 0.800. How about this one? This one's a little easier because they got the parts there. 0.975 and then 0.005. So 0.980. How about this one? Careful, it's not 5 points. 0.5. So it's 0.575, and then this is 24 thousandths more, so it is 0.599. So this one. Are we past the 25? Yep. And yes, we do have the 1,000, so it is 0.626. Point .425 and 0.9, so 0.434. This one? Actually, I'm going to do this. It's labeled as a 2 to 3 inch. What's that mean? 2.725, 0.022, so 2.747. The 2 3 inch just means instead of 0 point, it's 2 point, however many. How about this one if this is a 1 2? .875 and 23, so 1.898. How about this one? No label, so we're assuming it's a 0 1. Plus 13, so 0.338. What do you guys think? Okay. I'm going to scroll back here for a minute to this. This is called an inside micrometer. It's for measuring depths. And it also only has, this one actually only has ½ inch of travel on the barrel. So we have extenders. If I want to measure something more than a ½ inch, this here is a ½ inch extension. So I'll take it from a ½ inch up to a 1 inch depth. And then this is a 3 to 4 inch. That's a 3 inch extension. So right now, this one here, the way it's set up, has 3 plus a half. It's starting out at 3.5 inches. So then to that, you're adding the 0.225 and then another 10. So it's 3.735 inches is what that comes out to be. So the first thing we have to look for are those extensions. So when I look at this one, what do I have for an extension? Just the 3/4. That means it's 3.225 and then another 20. So 3.245. Do you guys follow that? Yeah, a lot of people say, I've never seen one of those before. So this one is 3.5. 3.5 we're starting at. Then here it's 0.325 and 12, so 3.837 inches. How about this one? 2.35, 0.24, so 2.374 inches. Let's see this one. 3.5, good catch. 125, and then the 10. 3.635. And this one. 4.5. We got the 4, we got the ½ inch, and then 4.75, and then the 24. So yes, 4.999 inches. Metric micrometer. Just like the caliper, these are millimeters. Unlike the caliper, they actually write them out as 15 instead of doing the 1, 2 for 10 and 20 and whatever. That is 15 millimeters. That would make this 16, 17, 18, 19, and 20. This would be 15.5 or 15 and a half, 16 and a half, and so on. The thimble here only goes up to 50. So that's 50 hundredths, or half of a millimeter. So if I'm reading this one, this is 20. Did it go past 21? Yeah, just past 0. So that's 21 whole millimeters. And what lines up with this line is what we read here, which is the 5. That's 500, so 0.05. So 21.05 millimeters. Make sense? So this is 15, 16, 17, 18 and a half. So 18.5. And then that lines up with 45. So 18.95 millimeters. If it goes past it, then you go add the half. Yep. So this is 5, 6, 7, 8 and a half. Oh, but we're at the 0, which means we actually just hit the 9. You can, if you look really close, you can see the edge of the line peeking out there. So that is 9 millimeters. How about this one? 14, and then that is 0.3 millimeters. This one, 15, 16, and 17 and a half, and that is 0.35, 17.85. What'd you think? Good stuff? Yeah, they can be hard to read, especially when you're putting them on paper like this instead of doing them on with a real caliper or micrometer in front of you. Okay, well, since we've got some time, I am going to take a look at Vernier scales. We're going to look at calipers first. On a caliper, you have the main scale. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. And actually, I got to be careful when we're using a vernier. It's labeled a little bit different. Let me. Just like on the micrometer, you had those quarter marks. For using a vernier caliper, we have quarter marks. You get the picture, right? Oh, extremely, yes. Now, you've got the edge. We had the edge of the jaw that lined up on the dial caliper. On a vernier caliper, you actually have a piece that lines up that has another scale on it, and it starts with 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 10, like that. Notice the spacings here are different than the spacings up there. This actually sits right up next to that. And where we read that main scale is where the 0 is. So let's say my 0 is right here. That is saying that this is 0.850 inches. Make sense? I'm past my second half. Now, what goes beyond that, instead of having the dial to read the thousandths, the Vernier scale extends here.
And the lowest part would go from 0 to 25.
Yes, this would go up to 25 because there's 25 thousandths between the quarter marks. What we do is we look here for the line that lines up with something on the main scale. Notice all these are just a little bit off from the main scale, except for this one right here, which is 11, right? So you add 11 thousandths to that. So this is 0.861 inches. Does that make sense? It's a real pain, isn't it? What's that? This is 10. Yeah, it's. Yep. So let me erase this. Put another one up. Yep, we'll get to that. So reading this, where do I read the main scale? At the 0, yeah. So this is 1.125. Then on the Vernier scale, which one lines up? The 9. This is 1.134 inches is what that's saying. That one's harsh, isn't it? We don't use a lot of Vernier calipers anymore, but there are things out there where the Vernier scale is used. The Vernier scale was an ingenious thing when it was came up with, because it allowed you to measure very, very small differences. What it is each of these lines here on the Vernier scale is 1/1000th of an inch off of the spacing for the lines up above. So, but because of that, they're that 1/1000th of an inch off, we can tell which one, by the proper one that lines up is going to be the one that's the right number of thousandths past. Okay. Sometimes the hard part is figuring out which one lines up, because there might be multiple ones that look like they're really close to lining up. A lot of times what I actually have to do is I actually have to, even on when I have the caliper in front of me, is I actually take the caliper and I'll tip it and I'll look at it sideways like this. If you're looking down the lines like that, you can see better. It's just like taking your piece of paper, trying to tell something straight. If you tip it like this and look down it, you can see any little slight crooks in that line. Or when you're looking at it like this, it might look really close to straight. Does that make sense? So, I mean, I a lot of times have to do that in order to be able to see those little differences. Here, the one that's supposed to be lined up is that one right there, which is 16. So now I'm going to read the main scale, which is, at the 0, is 0.475, and then 16 thousandths from the Vernier scale. So 0.491 inches. What do you think? That one's kind of a pain. Vernier scales and I've used them, I'm good with them, but I don't really like them much, to be honest with you. They're a pain, they're tough. You just got to remember how to use them. And that's just a matter of using them enough, because they don't appear that much anymore. 20 years ago, they appeared a lot, but they just don't appear that much. The dial technology has become good enough, they're precise enough with the dial. You know what happened was watchmakers got into the tooling industry. So the internals on those dial calipers is basically the watch workings. So they actually do make them now precise enough that they work. That's it? Yeah. Yeah. I mean, there's definitely use for them. I mean, they've got some accuracy to them. So let's take a look here now. You said a Vernier Micrometer. Well, ask and you shall receive. So there's the 4. Let's see here. So normally when we read a micrometer, we would round off to whichever marking we're closest to here. So this is going to be 0.450, and this is closest, probably still closest to the 12. So 0.462 inches. If it's a Vernier micrometer, it's going to have an extra scale up here above the main scale on the barrel. So it looks like this, 0, and usually it's 2s. It doesn't go up by 1s. So it might be 2. Like that. So when I look at this, when I see that there is a Vernier scale up here, that tells me that this is going to round down. So even if it were closer to the 13, it wouldn't matter. We would read it as 12. If there's no Vernier scale, we go to whichever one's closest to it. But if there is a Vernier scale, we always we round down. Now up here, this is the 4 that is lined up. Doesn't matter what it lines up with, it's the 4 that's lined up. So that is just 4,000, or 4 10,000ths you can put on the end of that. Oops, I should put a 25 there. That would be the 0. So what's this one going to read? Well, 0.625. Point is between the 20 and 21. Probably closer, might even be closer to the 21, but we're going to round it to 20. And then what lines up here? 8. Yeah, we rounded it down to the 20. So it might have been closer to the 21, but we always round down because there's a Vernier. If it wasn't the Vernier scale here, yeah, you'd go with the 21 if it was closer. So yeah, it's 0.645, and then we put the 8 on the end of it. So that's telling me that it definitely is closer to the 21, because it's 0.8. It doesn't matter. We're still using the 20. You do realize that this stretches my artistic ability to its limits. Just the fair warning. So read this one for me. 0.4. Is it past the 50? Yeah, because it's just past 0. Point. It's closer to the 2, but there's a Vernier scale, so it's not to the 2 yet, so we got to go down to 1. So 0.451, then the 6. So for the standard micrometer, the Vernier scale just adds that extra digit on the end. And the same happens for metric. We're not going to do the metric, but you might see some. Well, they do make Vernier ones that do have 0 through 9 here instead of 0, 2, 4, 6, 8. But on this one, you wouldn't be able to, no.
If it doesn't exactly line up, you can round it that way.
If one of these doesn't exactly line up,
Right.
yeah, that's a little bit more tougher to deal with. You would definitely just take the one that's closest to lined up. But yeah, it's not. There's some other things that go on there that we're not going to get into. Oh, he does. Okay.
They're making a lot more that way now.
Yeah. In your book, there's a ton of pages here. Page 297, exercise 10.7. That's the Vernier caliper. Page 299, and some of these may extend onto the next page. Exercise 10.8, that is the metric vernier caliper. I want to see if you guys can figure out what those scales mean on your own for the metric. I will warn you, there's a ×2 thing on the metric one. Be aware of. Watch it out. Just so you guys are aware, by the way, you'll never be quizzed on vernier. I'm not going to quiz you on Vernier Scales, but I'm just showing it to you in the homework. So for full disclosure, if the Vernier Scales make you want to pick up your textbook and throw it across the room, don't worry about it. As long as it's not a rental, go for it. 11.1 actually doesn't have any exercise. Oh, 11.1 is just reading a ruler. I'm just going to assume you guys can read a ruler. Okay. So there they are. Something to keep you guys busy over the weekend and for the next 11 minutes for some homework to get you started. Yes, sir. That is actually close. I got 39 something. That's what I had. So what'd you get for a radius in this? The radius. Something like that. 37 times 37 divided by 12 is this distance. Add 12 to that, now I know the diameter. Okay, there. Forgot to add the 12 to it. Okay, that'll do it.
Alright.
You're close, though.
I'm trying. You're driving me nuts.
Well, there's a reason that one was extra credit. There you go. When it comes to extra credit, I'm actually really tight. I mean, you have to do something pretty special to get extra credit out of me.
Really?